Hey there. So let's start off with a question here. How many ways can 10 distinct balls be distributed into 4 labeled bins? Right, so you may call the balls, say, B1, B2, B3, and so on until B10. And suppose you had 4 labeled bins labeled A, B, C, and D. And so what we want to count here is the number of possibilities, right? So one possibility would be to take all 10 balls and place them all in bin A, right? That's one combination that we can do. Or we can take all of them and place them into bin B. Or you can take maybe just the even or the odd numbered balls, place them into A, and randomly place the even numbers in B, C, or D. So how would we count the number of combinations there? Well, again, just think about the product rule here, right? For each ball, you basically have 4 choices, either A, B, C, or D. And so by the product rule, we're making these 10 decisions independently of one another. Each of them have 4 choices, therefore 4 to the 10th power is the total. Right, so that was an easy problem here. We had distinct balls, labeled bins, so it all works out. Now what happens if I make this small change to the problem and ask you, how many ways can 10 identical balls be distributed into 4 labeled bins? Right, so note here that the balls are all identical, meaning they're not labeled B1 to B10 anymore, but simply as B, for instance. Well, I shouldn't use B here. I was using B for bins. So let's call the bins bin 1, 2, 3, and 4 instead. So 1, 2, 3, and 4. So now we're asking the same question, right? How many possible outcomes are there when you take these 10 balls and drop each of them into one of these bins? And so one possibility would be, again, just to take all of them and place it into bin 1. Another possibility, maybe you put 2 in bin 1, 3 in bin 2, and then 5 in bin 3, and nothing in bin 4. And so on and so forth, right? So all of these 2 are possible combinations. And again, note here that since the balls are identical, right, we don't really care when each ball is placed into which bin. And so really, what are we counting here? Well, if you think about it, the only difference between these 2 combinations is where these dividers are between the bins. Right? So you can think of this as, instead of 4 actual bins, just think of this as 4 spaces with these dividers in between each space. Because regardless of where you put your bins, your balls, you'll always have these 10 letter B's in a row, right? You will always have 10 B's. So I'll write them all down like this. And each assignment of balls into bins simply corresponds to taking 3 of these vertical lines and dropping them somewhere in between these letter B's. So for instance, if I drop these vertical lines, 1 here, and 1 here, well, this exactly corresponds to the second combination here. All right, so whatever's to the left of the first dividing line is in bin 1. Whatever's in between the first and the second dividing line is bin 2, and so on. And nothing is to the right of the last dividing line. So in bin 4, we're placing nothing there. And so what this tells me is, well, in order to count the number of combinations, I simply have to do the following. basically count the number of rearrangements of 10 letter B's and 3 vertical lines. And we know exactly what this is. So 10 plus 3 is 13. You have 13 symbols here. And you have 3 of them the same, 10 of them the same. So either 13 choose 10 or 13 choose 3 is the number of rearrangements. Another way to look at this is simply by recognizing that this is just a permutation of a multiset, right? Which is the same thing as a combination if you just have 2 types of things, right? And so this is the balls in bins formula here, right? And again, the important thing here is to understand that any such rearrangement of these symbols corresponds to an assignment of balls into these bins. And so just to generalize the argument here, if we now had k identical balls, right, there's k of them, and we're placing them into n bins that are labeled. Well, what does this mean in terms of our rearrangements? Well, that means how many dividers do we have? We have these n-1 vertical lines separating each bin from the next. And so you have n-1 of these symbols. And again, each rearrangement of these symbols here maps exactly to one way of assigning. So an assignment of k balls into n bins. Therefore, the answer here is, well, how many ways can we rearrange these symbols? Therefore, the number of such rearrangements is, well, how many symbols do you have? It's k plus n-1 factorial over k factorial n-1 factorial. Again, by the formula for permutations of a multiset.